Assalamualaikum and hi guys. So in this video I'll explain on the next subtopics in Fourier series, which is the last subtopics in this chapter, which is half range expansion. So in this section or in this subtopics, we want to find the Fourier series expansion of a function defined over a finite interval. So to find the Fourier series expansion, we need to convert the non-periodic function to a periodic function, and it can be done by extending the definition of a function to the interval of negative L0 or 0L, so that the extended function is either even function or odd function. So even if you want cosine series, or if we want sine series, right? So such Fourier series are called half range expansion. So in this half range expansion, we have two types of expansion. One is Fourier cosine series, another one is Fourier sine series. So if you still remember in the previous subtopics, Fourier series for periodic function, Fourier series of a periodic function. Okay, for cosine, if you have even function, okay, your bn is equals to 0, right? If you still remember, bn equal to 0 if the function is even function, which is cos function. If the function is odd function, which is sine function, then you will have an equals to a naught equals to 0. Okay, so if you still confused, please go back to the previous subtopics 4.3. Okay, so Fourier cosine series form is this in this form. So this is the general formula for cosine series. Okay, where you have fx equals to a naught over 2 plus summation of n from 1 to infinity an cos n pi x over L. So where a naught and an is given by this formula. Alright, and Fourier series, for Fourier sine series, you have, when you have a not equal to 0, an equal to 0, you only have bn. So for this function, your formula, your general formula will be bn sine n pi x over L. Don't forget the summation of n from 1 to infinity. Alright, where bn is given by this formula. Okay, okay, now we go to example 8. Find the half range Fourier series, for fx equals to 1 minus x. The range is from 0 to 1. Okay, so from 0 to 1, fx equals to 1 minus x. So firstly, we start with the Fourier cos function first, Fourier cos series. So from this function, we need to plot your function. Okay, alright, so from 0 to 1, 1, 2, 3, negative 1, negative 2. Okay, so from 0 to 1, fx is equals to 1 minus x. How to draw? You can substitute in the values of x. Okay, when x is equals to 0, fx is equals to 1, right? So let's say here is 1, so you have point here. When x is equals to 1, fx is equals to 0. So you will have another point here. Okay, so this is the graph for fx equals to 1 minus x, where the range is from 0 to 1. Okay, this is x, this is fx. Now we want to find the half range Fourier series for cosine function, right? So for cosine function, it is even function. Cosine is even function, and it is symmetric at y-axis. So when it is symmetric at y-axis, then your graph will be like this, right? And you will have periodic function okay, like that. Okay, understand how to draw the graph. Okay, then the Fourier cosine series of fx is given by this formula, right? This is the general formula. So you need to find the a0 and an. Okay, so for this question, this is your fx and this is your L. L is equals to 1. So L is equals to 1 here. So a0, just now the formula is a0 is equals to 2 over L integration from 0 to L fx dx. So this is the formula and you need to find a0. Okay, so 2 over 1 is 2, from 0 to 1 fx is 1 minus x dx. So you have 2, then you have x minus x squared over 2 from 0 to 1, right? And it is equals to 2 1 minus 1 over 2 minus 0. So you will have 1. So a0 is equals to 1, and an is given by this formula, 2 over L integrate from 0 to L fx, and then you have cos n pi x over L dx. Okay, so your L is equals to 1. Okay, L is equals to 1, so you only have 2, from 0 to 1 fx is 1 minus x, then you have cos n pi x over L. L is 1. Okay, dx. So I have 2. For this, the integration of this, you can use tabular method, right? So by using tabular method, you will get 1 minus x sine n pi x over n pi minus cos square pi square, okay, from 0 to 1. And then you substitute in the values. You get, this is 0, sine 0 is 0, sine minus cos pi over n square pi square minus 1 sine 0 is 0 minus, so cos 0 is 1 per n square pi square. Okay, then you simplify, you will get 2. So since this is negative and this is positive, minus and minus and negative, then I'll put this one first. 1 over n square pi square minus cos n pi over n square pi square. Okay, then you simplify, you will get is equals to 2 over n square pi square 1 minus cos n pi. So n minus cos n pi, so if you have cos n pi, you can change to negative 1 to the power of n, right? So this equals to 2 over n square pi square 1 minus, okay, so minus cos is actually plus negative 1, and this is negative 1 to the power of n. Am I right? So you get 2 over n square pi square 1 plus minus 1. This is power 1. So if you have the same base, different power, then you can just plus the power, right? So you have n plus 1. N plus 1. Okay? So if let's say your n is 1, n is odd, if your n is odd, okay, if your n is odd at this side, alright, you will get if it is odd and then the total is even, right? If it is even, then here will be plus. If here will be plus, then you will have 2 here. Total is 2, so 2 times 2 is 4. Okay, so if n is odd, then you will have 4 for the numerator over n square pi square. Okay, but if n is even, okay, let's say n is equals to 2, so 2 here, so 2 plus 1 is 3, negative 1 to the power of 3 is negative 1, so 1 minus 1 is 0, so here you will get 0, so your function is 0. So now you have 2 different functions. Okay, so it is equals to, you will have piecewise function. One is n over 4 over n square pi square if n odd, and 0 if n even. Okay, so since you have 1 is 0, if n is even, then your function is 0, then we can simplify the function when n is odd. So since n is odd, okay, since n is odd, so n is equals to 2m minus 1. Okay, so you can simplify, it is equals to 4 over 2m minus 1 square pi square, where m is from 1 until infinity. Okay, Okay, this is for an. Then your function of fx, so fx is equals to your fx is equals to the formula of fx. So fx is equals to a naught over 2 plus the summation of an cos n pi x over L n from 1 to infinity. Okay, so your fx will be, just now a naught is 1, right? So 1 over 2 plus, hopefully you can see my handwriting here, plus the summation of n from 1 to infinity. An is equals to this one. Okay, an is equals to 4 over 2m minus 1 square pi square times cos n pi x over L. L is 1. Okay, so this is your function when you have the Fourier series of cosine function. Okay, now we go to Fourier series of sine function. Fourier sine. So to get the Fourier sine series, we need to extend fx to be an odd function. So to extend the fx to be odd function, your graph must be symmetric about origin. Okay, so just now we have 1 2 3, and here you have 1 2 3. This is fx, this is x. Okay, just now you have, when x is equals to 0, fx is equals to 1. When x is equals to 1, fx is equals to 0, right? So just now this is your graph. So if you want to do the half range expansion for sine series now, your graph must be symmetric at origin. Okay, at origin. So your graph will be like this. This graph is symmetric at origin. So you have to repeat the graph, since it is periodic function, right? So you must repeat the graph to be an odd function graph. Okay, so you will have here, and this one will be here. Okay, so basically this is the graph for odd function for the given function. Okay, so after you draw the graph, you need to find the Bn. Since it is odd function, a not equals to 0 and an is equals to 0, so you only left with Bn, right? So this is your formula. Okay, where Bn is equals to this formula and L is equals to 1, so you need to calculate Bn. Bn is equals to 2 over 1 is 2. From 0 to 1, fx is 1 minus x sine n pi x over L. L is 1 dx. Okay, so solve this by using tabular method. You will get 1 minus x, then you'll have cos pi x over n pi. You have plus sine n pi x over n square pi square from 0 to 1. Okay, then you substitute the values. You get negative here. Okay, so negative 2. So if you are not confident with my my solution, you can try on your own. Okay, try whether it is the same or not. So you substitute in the values, you get 0 plus 0 minus 1 over n pi plus 0. Okay, is equals to 2 over n pi. So Bn is equals to 2 over n pi. So your fx for Fourier sine series is equals to the summation of Bn times sine n pi x over L. This is summation of n from 1 to infinity. Bn is 2 over n pi. And you have n is sine n pi x. Okay, so this is the function when you find the Fourier sine series. Okay, so that's all for half range expansion. So now I want you to try example 9. Okay, sometimes the question can ask to find the Fourier cos series or Fourier sine series, or the question also can ask to find the even extension. So even extension means you need to find Fourier cos series, and odd extension means that you need to find Fourier sine series. Okay, so I want you to try example 9. This example 9, do all questions, okay, and submit as assignment as usual. Assignment 4.4, only this question. In the next page you have exercise. Okay, so for this exercise, just do it, no need to submit as your assignment. You have 6 questions. Okay, just do it, no need to submit. Okay, just submit this example 9 as your assignment 4.4. okay, so I think that's all for chapter 4, and we have done chapter 4. So basically chapter 4 is about Fourier series. So in Fourier series you have learned how to show whether the function is periodic or not, and then you already learned the even and odd function, and then you have learned how to find the Fourier series when you are given even or odd function, and the last one is this one, Fourier series for half range expansion. Okay, so that's all for chapter 4, and I'll see you guys in the next chapter. Right, thank you.